Everyone. Okay, so now I'm going to talk about Python syntax, a little review of what we learned last time really quick, and then we'll go into branching and looping, which usually involves if and if else and elif statements and while loops and for loops. So those are our two main kinds of loops. For loops we usually use when we know how many iterations we're gonna do, whereas while loops we usually use when we don't know how many. So let's see what that means. Okay, so we have these slides that are on our canvas. So just a reminder, for Python syntax, we for our comments, proper syntax for block comments is to use the triple apostrophes and or triple quotes, and when we have code blocks, our indentation is crucial. So for example, if we have an if statement, we can either use two spaces here, four spaces here, or a tab, which is the same as four spaces. So whatever we indent is within, for example, this branch, if B. So if B is true, all of this text will be printed. Else, all of this text will be printed. So we can have as many lines as we want added to our if statement. However, it's crucial that they are indented the same way throughout the program. So if you choose two spaces, you have to use two spaces throughout your entire code. And if you use four spaces, you have to use four spaces throughout your entire code. So if we want to add more lines, for example, if B is true, we can just under this print statement, but that also has to be indented with four spaces. So if statements are are usually what we use when we want to do something called program branching. So basically a Python code is also known as a program, is usually just a sequence of statements, one after the other. And a branch is specifically when we execute one series of one sequence of statements if something is true, and another sequence of statements if something is false. And so like I was saying, we might have the case where we don't have any new statements if something is false. For example, this is just if true, and then we print true. So that's just an additional line is printed in our program if something is true. And in this diagram here, we have what looks like each of these blocks here probably has some code in it. So we'll see in a second what that looks like in code, where we have if something is true, then execute a sequence of statements, and if something is false, then execute another sequence of statements. So for example, if we have else here, so if something is true, then we print true. Whatever is printed under else is what happens if this is not true. So if that's not true, then print wasn't true, is what it says in this specific code block. So false block is this print wasn't true, and our true block is print true. Whoops. Okay, so and here's kind of another example where we are in our Python shell, in our IPython shell. So say we create this variable x and we call it 6543, the integer 6543. So it's an integer. So remember this modulo from the last lesson, takes the remainder of an integer divided by the number here, so 2 in this case. So if 6,543 divided by 2 has a remainder of 0, then we know that number is even. Otherwise, it's odd, right? Because something can only be even or odd. So we know that, so we're printing odd here. So whenever it's not even, print odd is printed. So this statement here happens if it's even or odd, right? Because this isn't indented, like I was just saying. If we wanted this statement to only, or I can't highlight it here because it's in this image of the IPython shell, but if we wanted done with conditional to print only if it was odd, we would have to indent it with these 4 spaces here. But it's not indented, so that means we've left this branch and we've went on to more code. So it would be similar to this block of code down here. So once we've already went through the false block or went through the true block, we go back to the main program. We can also have nested if statements, or we can nest for loops. We'll see soon. We can nest multiple loops and if statements, and that will be something we want to do a lot in more sophisticated code. So we can see the output right here. So let's see what that might look like. When we say nested, that means that, say, we want to do if it's even, then if it's even and less than 5, print less than 5. So then we would have another if statement here, but it would also be indented. But then we would indent even more for the block of code that's inside less than 5. So let's see examples of that in this lecture and the next one, if that doesn't make sense. Okay, so loops. So loops is usually when we want to iterate over a block of code multiple times or many times. Or just keep iterating until something becomes true and we don't know how many times we want to iterate. A loop is good. Because we don't have to rewrite that chunk of code multiple times. We only have to write it one time. And the loop itself will tell how many iterations. In for loops, we usually use a range function, which we'll see soon, and that it can be used to provide the actual range of numbers we want to iterate over. So, for example, if we have a while loop, like I was saying, a lot of times you want to have an if statement inside, sometimes in a for loop too, where that statement evaluates a true or false. Or sometimes we do while true or while a statement that may be true or false, and then a colon, and then we have our code block inside. So we usually have a condition in while loops, sometimes also in for loops. And while that statement is true, we keep iterating through the code block. So for example, we like say this is our loop, then this test is representing the if-else statement or the if statement. And we test if it's true. If it is, we keep going and do the loop body and then iterate again. So if we had the if statement up here, as we'll see an example soon, and it wasn't part of our while, right after our while and before the colon, then we would have to put a break, what's called a break statement. So a break will break us out of that loop no matter where, no matter what. So if we write break under our if statement, then it will get us out of that whatever loop. So we can do that in a for loop or a while loop. But it will go on to the rest of the main code here. So yeah. So for example, sometimes, like I was saying, we usually have either a condition here right after we write while, or we have just put true and then we have an if statement inside. So in this case, we're just looping while true. So this never changes. This is always says true. So the only way to quit this loop is to write a condition with a break, or just have a break, which will go on to this. It will move on to the rest of the code down here. So which we know the rest of the code starts here because it's not indented. Oops. So all of these lines are 4 spaces indentation. So this is the loop, what's called the loop body. So within the loop body, we have this conditional statement. So what we have to be careful of, as we'll talk about more when we talk about time complexity, is we have to make sure we don't have an infinite loop, because if for some reason this never becomes true, then we can never break out of the loop. Then our program will get stuck just looping through this, and it will never get back to the main program, which we want. So this break is within this if condition. So this is just doing a mod 11 and this is doing a mod 12. So if both of those are true, then we break. So a lot of times we have a number we increment. So this is called incrementation. So we created this integer 1, and then down here we are incrementing by 1 in each loop and each iteration of the for loop. So the number is changing. So if initially this isn't a true statement, then hopefully eventually by incrementing by 1, we'll find something, which we will in this case if we think about it, because even if we have to go all the way up to 11 times 12, some number is going to be divisible by both 11 and 12. So remember what we talked about in the last lesson, when we have and the Boolean operator here, that means both statements have to be true, right? We have or, then only one has to be true. But we have to have divisible by 11 and divisible by 12 here. Okay, so for loops. Okay, so like I was saying, for loops, we usually run through a number in a sequence. So for example, we might say list numbers. So since we have it after this in keyword here, that will tell the Python shell, the Python interpreter, that we want to run through each of these numbers in this tuple one at a time. So num here is our iterator. So we created an integer total 0, And so for each time, this total is going to be incremented by a number in this tuple, because when we have the variable that whatever variable we put right here in between the 4 and the n, that will on each iteration represent one of these numbers in our sequence or tuple, or our range function, as we'll see soon. Okay. So go on. Okay, so like I was saying, we have this really useful range function. That's what we use most of the time in our for loops, because it will simply create a list of numbers. So for example, if we just put one input into the function, so in here, I is going to represent whatever number we are in this range. So it will be 1, then 2, then, or it will be 0. Since Python starts at 0, it will loop from I will be 0, then 1, then 2, then 3. So for example, if we want to use a range start, stop, step, so we can also have two inputs to the for loop or to the range function. So if we put 2, then that will be our starting number and this will be our stopping number. And remember, this stopping number, so like 10 here or whatever number we put here, is not going to be a number in our list. We'll go from the first number all the way up to 1 before this number. And step is an optional input as well. So for example, if we want to count by 2s, we would put 2 there. If we want to count down, we put -1. For example, if we have an range from 10 to 20 counting by 3s, it will be like 10, and then 10 plus 3, 13, and then 13 plus 3, 16, and 19, and so on. So those are here. Okay, so this is the end of these slides. So I'm going to start on this lesson, lecture 2. So we're going to talk about some actual code examples here. And then whatever I don't finish, we can do in the next lesson. So remember that Booleans either are evaluate either to true or to false. So, and we can evaluate a condition here. We can do a test and assign that to a variable. And then whatever the result of these are, for example, 4 greater than or equal to 2, will be one of these Boolean type variables. So these will be type bool. If we printed it, it would say type bool. Or Boolean. So obviously this 4 greater than or equal to 2 would be true, 100 less than 2000. So you get the idea. So does true equal false? No, that's false. So that would be false. Does 1 equal 2? No, that'd be false. Remember, our difference between our or and our and, like I was just talking about before, if we have an or, then only one side has to be true. If we have and, then both of these have to be true. So we can go through and so true, and so we have to have true and true to have true for and. That's the only way and is true. So all these other ones with a false on the left or the right or both is going to be false. Whereas or, it's mostly going to be true when we're comparing true and false. So true and true is true. True or false is still true. False or true is still true. The only way that it can be false is false and false. Okay. Not is the inverse. So it will negate whatever if it's true, it'll be false. If it's false, it'll become true. So let's create a Boolean. So remember, true and false are also 1 and 0. So create a Boolean variable with the 1. So instead of it being an integer, we can create it as a Boolean variable. So bool 1 and bool 0. So that's just a reminder that true, like for example, in our while loops, if we want to do while true, we can do while 1 instead. If we want to do set something to false, we could assign a 0. Okay, so a string is true, and usually integers and floats are true otherwise, besides 1 and 0. If statements, like we were just saying, it's a branching structure. So it begins with a test. If the condition evaluates to true in the test, the code block below will be executed, otherwise it will not. And sometimes if it will not is an else block where we have code that evaluates if it's not true. Okay, so sometimes we also have if. So that's when we have code blocks that we might want to evaluate for multiple conditions. So for example, if, like we were just doing, and then elif, ELIF, we have a different code block, so maybe another condition. So this is when we have more conditions besides just something being true and something being false for the else. So these are just some more examples you can look at. Let me know if you have any questions. So for example, if we had, let's run these through together. So just for a test. So it's going to connect when I press play. So we have an integer 10. If type x is an int, all this will be printed. So yes, it is. So they should be printed, right? Okay. So if type x is not an int, then this is printed. So nothing is printed here. So 2022, if it's even, then mod 2 will be 0, right? So this should print instead. But if we had 21, then it's not even, right? So the other code is print a is an odd, it prints is an odd number. The other code block is evaluated, is executed, sorry. Okay, so this one we have two integers, one divided by the other. If that equals 2, then this will be executed. Otherwise, it won't be. And then since this isn't indented, this is our regular backdoor code body after we're done with the if statement. So nothing happens because 300 divided by 100 is not equal to 2. So none of these lines are evaluated. And this is like I was saying with the nested if statements. So we might have, say, mod 2, say, let's make this even again. So this nested one evaluates. And we can ignore that. That popped up. Okay, so if we have 2022 mod 2 here, that's going to be divisible by 2. So let's see what happens. So right here, then if we had 2025, it would be divisible by 3 and not 2, right? So this would be evaluated. But you have to be careful because if we have one condition that's true up here and another one is true down here in our elifs, it will just evaluate the first one. And if we wanted both to be evaluated, we would have to test both conditions. So we'd have to test it within that elif somehow, either with a nested or adding it on to the condition itself or adding another condition. So we made this even. So 2022 is even, but it's not divisible by 3. So it's gonna print this divisible by 2 and not 3. Or sorry, 2022 is divisible by 3. So we can test it. 2022 divided by 3 is a whole number. So it is divided by 3. So our code worked better than my immediate thought. For some reason, I was thinking that would be divisible by 3. But our code told us that it is divisible by 3 because we tested it here. X mod 3, it's divisible by 2 and 3. So this done with checking, right? That was printed on each case. So that's printed on each case because this is outside the statements. This is back to our code body. It's not indented. It's not underneath any of these blocks. And same with this checking if it's divisible by 5. So if we have something that's divisible by 5, this is back in our original code body. This is another if statement. So this will always be tested as well. So let's try. So we see I made 2025, which is divisible by 5. And now we can see that this is executed. Okay. So here we have other examples. So for example, we have these, if these are both true, then only if both of these are true, then this will be evaluated. But if just this one is true, then this will be evaluated. Otherwise, any other case, this will be evaluated. Okay, so in the next lesson, I'm going to go ahead and walk you guys through creating an example program where we're going to take inputs from the user. And we are going to see which one is the largest. We'll have some examples of while loops. And finally, we will actually we'll have some more examples of range, and then we'll actually create a program in the beginning, putting it all together.